If your Wi-Fi was visible in a visible spectrum for the human eye, how bright would it be? Everyone knows this kind of red LED. Imagine your Wi-Fi router was an LED light like this. How much current, how much watt, how much voltage does this LED require? The average Wi-Fi router is around 100 milliwatt. Now, first look up the numbers of this LED, this LED. If your Wi-Fi router was in the visible spectrum, I did choose for the red LED since this is closer to the spectrum of the Wi-Fi router. First, you have to look up the voltage of the average red LED. It can usually be up to 2 volts. So we're gonna write this down. Voltage is to 0 volt. Now we have to look up the current it uses. Now we can scroll. I've looked this up. You find all kinds of charts. Different colors of LEDs have different kind of power requirement, like different voltage, but usually more current, current in amps. Look, I already looked this up, but you find out it's 20 milliamps. Now, your average Wi-Fi router is 100 milliamps, but the LED in the red example is just 20 milliamps. Now, we want to calculate how much power this consumes. We calculate it as follows. 2 volts times 20 milliamp equals 2 times 20, 40 milliwatt. Your router is doing average 100 milliwatt. Now, what can you now think about if you could see your Wi-Fi signal at in the visible spectrum, if you could really see your Wi-Fi router in the visible spectrum? Well, let's go back to this kind of LED and look up the brightness. Here I found an image. Oh, I can't zoom in. Look at this red one. Your television has a red LED probably when it's in standby. The more closer you hold your eye to the LED, the more brighter it actually affects your eye. Since it's in the visible spectrum, this red LED, your pupils will close. But a router Wi-Fi antenna, its signal will of course not affect your pupil eye dilation. Now, take this red LED. You have seen, I suppose, red LEDs everywhere in your average technological devices. Now, we're gonna go back. Your router is doing 100 milliwatt at its antennas. That happens to be 20 dB. 20 dB. 23 dB is 200 milliwatt. Yes, but we consider your average router, which you have got, which you have gotten from your provider. Now, we now know a 40 milliwatt brightness means just this. The average red LED is just 30 milliwatts. Now, take 2.5 times the brightness. Take 2.5 times the brightness of such a red LED which you have in, for example, your television, and you can understand how bright your router is at 100 milliwatts. But if you want to consider, can you look at an antenna from your Wi-Fi router, you should first try at 40 milliwatt to come as close nearby a simple red LED. Go closer to the red LED in, for example, your standby television. It does not hurt your eye. If you get closer, there is a law, and that law is R squared, where R is the distance, and it is 1 division by R squared. The distance is in meters. So, in generally, now let's take a phone tower station. Phone tower. Let's look what we've got. A cell site, it's what it's called. These are far more powerful than your Wi-Fi router. I cannot recommend to look. Actually, I cannot recommend to look in the sun, of course, but I cannot also recommend. I can also not recommend watching towards a cell phone tower. These are far more powerful. But now let's take your phone. Let's take your phone. Assuming it is autocorrection. Assuming it is 1000 milliwatts. Now, you already know a simple LED from your example standby television is 40 milliwatts. Now, I can get a simple calculator. Where is the calculator? Utilities, calculator. Imagine you are phoning with 1000 milliwatts divided by the wattage of milliwatts of 40. It's 25 times as bright. Your phone, when you are calling from a pretty distant location of the nearest cell phone tower, is 25 times as bright as this LED. Your phone will be, if you could see the light coming from it, since radio waves are simple in the light, just as the human eye can see. Your cell phone will simply do 25 times the brightness of a simple red LED. I hope I explained some questions. You can look in a 40 milliwatt LED. That is this one. But if you come closer to the LED, it might be a little uncomfortable. So I do not recommend watching in an LED, but you do not have to fear about it. It will not harm you. But if you go to a cell tower, before maintenance, they shut them down. Like you do not stare in the sun, you should not stare in a cell phone tower. These are very powerful. If you do not look at them, they are just like not staring in the sun. You do not stare in the sun, no matter, you cannot see behind ultraviolet, you cannot see the deep infrared from the sun, but it is there. Simply do not watch in such a cell phone tower. Now, let's come back to the conclusion and answer the question. What if you could see your Wi-Fi router, its brightness of as if it were just an ordinary light? Now, we have answered the questions. We divide 100 milliwatts by 40. Now, that is a little more than 2, but I want to be sure. 100 divided by 40, around 2.5, I should, yeah, 2.5 times the brightness of your standby red LED television LED. That is how much power your router is sending, and if you could see this in the visible spectrum, that is how much it would be. But as you know, why can a Wi-Fi signal reach so much distance? That is because of the frequency of the light, and that is far too complicated to discuss in this simple video, which was about answering a simple question. If you could see your router antenna in the visible spectrum, it's just 2.5 times the brightness of your standby television red LED, for example. Now, I hope that answers the questions. People that have underwent surgery for cataract can see sometimes behind normal human visible spectrum, more forwards towards the blue. Maybe I should look for visible spectrum. Oh, NASA, what is this? Visible spectrum. Okay. What is visible to the human eye? People with cataract actually can see far more bluer than people without cataract surgery. People with after having cataract surgery can sometimes even see towards violet, far behind blue, and that is too complicated to answer in this topic. But there is a simple reason why your Wi-Fi signal travels that distance. Of matter you are made of, you are 99.1234567. You are consisting of 99 of and 1, 2, 3, 4, 5, 6. You consider of this percentage of nothing. Of matter you are made of, you are 99.9999998 100% nothing. Emptiness. It wants to autocorrect again. Emptiness. It wants, no. Wi-Fi travels this distance because everything around you is mostly considered of nothing. In essence, everything is 99. I've told it. Okay, I've told it already. Around 100% almost, you are made of nothing. Just this little digit far behind the dot. You are existing of real matter. That is far complicated, but take a neutron star. I think I probably should stop now. I have answered your questions. The evidence that you are existing of nothingness almost with is that you can receive even GPS signals from satellites orbiting planet Earth. They go through even the atmosphere, they reach you. Now, not all matter is the same, since it requires a lot of matter. It requires 6.0 times 10 to the power of 23 atoms to block a photon, e.g. for example. That is incredibly lot, you might think, but it is not true. 6.0 times 10 to the power of 23 atoms, a 6 with 23 zeros. It is not much. I wish you a nice day, and I hope I have answered your questions. I would have wished to show you more. Yes, I think Microsoft Windows products suck, but that is my opinion, and don't waste your time using Microsoft products. Bye.